I'm going to talk about slope fields. I'll assume that you know what differential equations are. If you don't, I would invite you to watch my introductory video. All right? So, slope fields are graphical representations of solutions to differential equations. Let me repeat that. Slope fields are graphical representations of solutions to differential equations. We know that we can represent a single function by a graph. Maybe the graph is a line, maybe it's a parabola or something else. But we can also represent a set of functions, okay? And the representation is referred to as a slope field. So I think an example will be most revealing. So let's solve the simple differential equation y prime equal to 2. So we'll take the antiderivative of both sides with respect to the independent variable, let's call it x. So we'll arrive at y is equal to 2x plus c. So for different values of c, I have different linear functions. So the solution set for that differential equation actually contains an infinite number of different linear functions. So the best we can do to represent the entire solution set is to plot a few of the elements of the solution set. Okay, so the graphical representation will involve several lines, each of which corresponds to a function that's a solution to the original differential equation. So give me a minute to make an xy coordinate plane. All right, so if c, the constant, was equal to 0, then the graph of the corresponding function would look something like that blue line. If the constant c was equal to 1, we would have that blue line. All right, and so we can plot the corresponding line for example, c equal to -1, c equal to 2, c equal to -2. So there you have it. That is the graphical representation of the solution set to the differential equation y equal to 2. Now, why is that called a slope field? Well, I don't want to get too much into into a discussion of fields, but basically a field is a fancy name for a function of space. Okay, like you can define a temperature field. The weatherman tells you the temperature for various cities in your state. That's a temperature field. You can define like the elevation on a map in front of you. You can have, so that's an elevation field that for every point on the map there's a different elevation or altitude. Okay, so how does that apply to this? Well, for every point in the xy coordinate plane, there is a slope that can be determined from the slope field. In this case, all the points correspond to a slope of 2, all right, but for more complicated slope fields, the different points will correspond to different slope values. Okay? Let me show you a slightly more complicated example now. So what about the differential equation y prime equal to x squared? And by the way, I'm showing you examples where you could solve the differential equation, couldn't you? Okay? For this example, we could take the antiderivative of both sides. But I don't want to do that because I want to show you that you can find the slope field even without finding the solution to the differential equation. Okay, that's huge. You can get a graphical representation even before you know what the solution set is. Okay? Let's pretend that we didn't know how to solve this differential equation. Watch me determine the slope field anyway. So give me a minute to make a xy coordinate plane again. All right, so watch this. Do you agree that for every point on the xy coordinate plane, we know we could find out what the corresponding x and y values are? Now, do you also agree that I can use those x and y values? I can plug them into the original differential equation to get what the slope has to be? For example, let's pick the point 0, 1. Okay? The point 0, 1 has an x value of 0 and a y value of 1. Well, we know that we have to have a corresponding slope of 0 because 0 squared is 0. So therefore, for the point 0, 1, I'm going to put a little line segment that corresponds to a line with a slope of 0. Now, doesn't every point along the y-axis have an x value of 0? So can you see that every point along the y-axis is going to correspond to a slope of 0? So whatever the slope field is, I know that there's going to be lines going through the y-axis with the slope of 0, curves going through the y-axis. All right, you see how I determine that? Now, let's focus on points with x values of 1. All right, like 1, 1. So, can you see that the curve through the curve that goes through that point, the curve, not multiple curves, that has to have a slope of 1, right? Because 1 squared is 1. So let me go ahead and put a little line segment with a slope of 1. And 1, 2 is going to have also a slope, correspond to a slope of 1. And same thing with 1, minus 1. Okay? And the points with x equal to minus 1 are also going to correspond to a slope of 1. And so what I'm doing is I'm slowly getting an idea of what the slope field is going to look like if I knew exactly the lines that I need, the curves that I need to trace. And then for points with x equal to 2, they're going to correspond to points with the slope of 4. So I'll have to draw lines with a greater slope. All right, and then points with x equal to minus 2 are going to be the same. In fact, the slope field is going to be symmetric. The right and left sides of the y-axis are going to be the same. Okay, so you could keep finding the corresponding slopes for more and more points, but I hope that you are getting an idea of what what the slope field is going to look like. So you're going to have points like this. All right. Now, again, let me emphasize that I was able to find the slope field without actually solving the differential equation. Okay? Let's do another example. In fact, why don't you try this example first? So try to find the slope field for the differential equation y prime equal to minus 2xy. All right, so pause the video and do that now. All right, so I'll go ahead and work it out too. So give me a minute to make, again, an xy coordinate plane. And yes, we could use the method of separation of variables to solve this, and maybe you did, and if you did, that's wonderful. But just to show you that you can do it without solving it, I'm not going to solve using the method of separation of variables. Let's see. So for points along the y-axis, x is equal to 0. And so minus 2 times x times y is going to equal 0. So the slope's going to be 0, just like in the previous example. What about, let's see, what about 1 comma 0? In fact, what about all points along the x-axis? They all have a y value of 0, so we will have all those points correspond to a slope of 0. And let's try 1 comma 1 now. 1 comma 1 has x equal to 1 and y equal to 1, so minus 2xy is going to equal minus 2. Okay. For 1 comma minus 1, we're going to have positive 2. And for 1 comma 2, we're going to have minus 4. Okay, and for 1 comma minus 2, we're going to have positive 4. And let's try minus 1 comma 1, we're going to have positive 2. And then minus 1 comma minus 1, we're going to have minus 2. Okay, and so you can keep again tracing out points, and I'll go ahead and tell you what the solution is. But you would keep not tracing out points, but you would keep finding corresponding slopes for more and more points. Okay, and you would get something like this. All right. Let's do one more example together. Would you please take a shot at finding the slope field to this differential equation? Y prime equals y minus x. So pause the video and try that now, please. All right, so I'll go ahead and work that out. So give me a minute to finish this XY coordinate plane picture. And I am going to do the following. I'm going to find regions of the XY coordinate plane that have, where all the points correspond to the same slope value. So let's say that I wanted y minus x to equal 0. That would be the point with y equal to x. So therefore, all the points along that blue line will have a slope of 0. So I can put lots of little horizontal line segments to denote that. And what about a slope of 1? So y minus x equals 1, y equals x plus 1. That will, let me draw the line in blue that corresponds to y equals x plus 1. All right, and so all points along that line correspond to a slope of 1. So actually the blue line has a slope of 1. So I'll draw little red dashes along that line. And then let's do a few more lines. So what about, let's see, what about, well, let me do this. Let me get a few points, isolated points. So 2, 0 is going to have a slope of minus 2, and 0, 2 is going to have a slope of positive 2, and 1, 0 is going to have a slope of minus 1. 0, minus 1 is going to have a slope of minus 1. 0, minus 2 is going to have a slope of minus 2. And so I know what the solution looks like. So let me go ahead and show you what you would get if you kept finding the slopes that corresponded to more and more points. It almost looks like water coming out of a garden hose.